Hey everybody, welcome back. We're in the last section of chapter 8, man. We're starting to head for the home stretch. This is the fun part. Okay, we've already talked about, I always tend to draw this same triangle, don't I? Okay, let's make this thing get crazy then so I don't have some. Ah! That was ugly. Let's, let's call this A, B, and C so I know that this is angle C, angle A, and angle B. Now remember when we proved the law of sines, again, I don't know why your author stuck this at the back of 8.4, but it's pretty simple. Remember how this works? I know that the area, I'm going to write area so I don't confuse it with angle A. I know that the area of the triangle can be written as either 1/2, I can go A, B, sine, big C, right? Remember this guy's the included. All right, so if I have C and I have two angles on either side, I'm golden. I know also, remember we proved this. I've got 1/2, I can do B, C, sine of A. You remember how we proved that? Okay, let me change the color. Ooh, lavender, I haven't used that. Remember I cheated. I just built a little height there that is at a right angle, and then I used the fact that I could figure out what this height is, and life gets good. I should probably know. Again, I don't want to drag you guys through the proof of it when we did it back in 8.2. I can also do 1/2. What am I missing? B, C, sine. Wait, I just did that. What a ding dong. AC, sine B. And really, all I'm using, what did I say? AC sine of B. Really, all I'm using is the fact that the area of any triangle is 1/2 the base times the height. And then I did some fancy schmancy trig to figure this out. Well, it wasn't even all that fancy, right? I just used sine and acknowledged that this was the height for this guy, and this is the height for this guy. And the height for this guy gets a little trickier because I got to come in at some weird angles out here to build that height, but it's still easily drawn. That's it. That's it. And we already did this. Remember how we then divided through by 1/2 ABC, and it gave us our law of sines, which was a lot of fun. All right, so I'm not going to insult your intelligence by making you grind through that again. Now, believe it or not, there's only one other formula, and this is called Heron's. And I'm not going to prove this one because it's basically just a whole bunch of algebra together with a couple of identities from trig. All right, but Heron's formula simply says this. Formula. Now notice, if I have two sides and an included angle, I can find the area here. What if I'm in the situation of what's going on here? Of side, right? So I don't have an included angle. Well, I suppose you could say, well, Ripley, I now have a way to find at least one included angle from law of cosines. Absolutely, you could. But what ends up popping out is simply this. The area is equal to, hopefully you guys have seen this before. We're going to have S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C divided by 2. This is affectionately known as a semi-perimeter, hence the S, a semi-perimeter. Okay? So, let's do one of these. Let's do one with, because this can get a little bit nasty. Let's start with our good, let's start, I'm having a hard time with these vertical lines today, or lately, as it were. Let's start with a good friend. Let's start with a right triangle whose area we already know. All right? I'm going to make this, let's make it a 6, 8, 10. So this is 6, and this is 8. And this is 10, because I want to show you how to use this, because you got square roots, you got all kinds of garbage there that you got to be real careful of. Now, what do I already know that the area of this triangle is? It's 1/2 the base, which is 6, times the height, which is 8, and last I checked, that's 24 square units, right? Units square. All right, now let's put Heron's formula into effect. So first thing I'm going to do is I'm going to find the semi-perimeter, which is 8 plus 6 plus 10 divided by 2. Which is 14 plus 10, 24 divided by 2 is 12. Now, according to Heron's, I'm going to end up with the square root of, now here we go, 12 times, now 12 minus 8, let's call this A, let's call this B, and let's call this C. So 12 times, pardon me, 12 minus 6 times 12 minus 8 times 12 minus 10. right? Now remember, we already know what the area is. We're just taking this thing out for a test drive. So 12 times 6 times 4 times 2. Well, look close. You may say, well, Ripley, what is going on? That's going to be an ugly square root. Not really. Look close. Do you agree that 2 times 12 is 24? So this is the square root of 24. And then 6 times 4 is 24. The square root of 24 times 24 is equal to the square root of 24 squared, affectionately known as 24. Isn't that awesome? It's fun to use. Now, clearly, the problems that I'm going to throw at you are not going to be as gentle. Why? Because I'm evil. But that's it. And by the way, for 8.4, that's it. And I'm signing off. We'll do some problems in class. It'll be a hoot and a holler. Thanks for your time and attention. Have a great day.